Here's prelab for lab 5 molecular models, and a model is a representation. And here the models are much bigger than atoms. You can't see atoms and molecules. Well, at least most molecules you can't see. You might be able to see a perfect diamond, but those are very rare. But you won't be able to see the individual atoms. So we're using these clay models to model the atoms. And so let's move on to go here. This is a theory called valence shell electron pair repulsion. Combined here, these are the Lewis structures. Basically, if there's two things, so if you can imagine it like in a dance club, if there's a girl in the center and there's two guys, they actually kind of form a sort of a sandwich. The idea here is that they're as close to the girl as possible, but they're as far away from each other because they find the girl attractive, yet they find each other repulsive. So that's a straight line here, 180 degrees. If there's three girls dancing around, three boys around a girl, or it could be three girls around a boy, whatever kind of club you're going to, I guess. Here, same idea. They want to be as close to the males want to be as close to females as possible, but as far away from each other, and so it forms this triangular shape, triangular planar with an angle here of around 180 degrees. And then here, well, let me skip to here, tetrahedral. Of course, there's not in 3 dimensions. If you're dancing on the floor, there's a plane. But if there are 4, I know it would form a box around the girl. But if they had 3 dimensions to work on, the 3 would crouch down underneath, and then 1 would stand on top of her head. Well, that obviously doesn't work. But this works here. You can see that there's atoms here. There are 4 things. All 4 things are atoms. This one here, there's 3 atoms and 1 lone pair. It forms a pyramid. And if there are 2 lone pairs and 2 atoms, this forms a bent structure. Why? Because right here, this one here is bent. The electrons are just kind of these fuzzy balls. They don't really do anything for the molecular geometry. This is a bent geometry. This is pyramidal, and this one's tetrahedral. This one here with 5 things, this is a trigonal bipyramidal. That means that there's this planar. There's a trigonal planar right here. These chlorine, phosphorus. There's a plane here with all, well, 4 of these atoms. These are all coplanar. And then a 90-degree angle to that, above and below, are 2 more atoms. An octahedral, this one here is all these atoms all have a 90-degree angle when you put this out. It's a square planar here. There's this plane right here with all these atoms, and then these above and below, all at 90 degrees. And so you can see here, this is a very symmetric 90-degree arrangement. Everything's boxed in. And so what are we going to do? So here, I'll give you the exercise. This BeCl2, there are 3 things. So beryllium's the central atom here. So there are boron and carbon. These are all the central atoms. Regions of electron density. This has 2. So 2 regions of electron density. If you go up back here, this is linear. This one here, there's 3. And 3 is going to be here, trigonal planar. And likewise here, carbon tetrabromide. This is going to have 4, that's tetrahedral. And I already talked about this, if you can just back it up. Now the magnets are fairly easy, you throw them together, it shows you even the picture with this. This is all fairly easy. Now, part 2 with marshmallows. Of course, there's also a lot of these that have the clay in them, so using the clay. So you take them and you form the clay. And then going through and looking at these, you basically remake the shapes here. So you redo these shapes, but you do them with the clay that's in there. And then you can see here the linear means a line. So if you have a toothpick and you have two atoms, there's only one choice to be linear. You can make linear with three atoms as well. The planar part, the bent, just like water. And a hint with this: if you make the tetrahedral one, you can make a tetrahedron and then rip off one of each to form the pyramid and the bent. So that's an easy way. If you can make the tetrahedron, all you do is you rip one out for that and rip one out for that. In the bipyramid, you make a planar one and then you put one above and below, a 90-degree angle to the plane. Octahedral, make a square plane, and then all 90-degree angles, and then you put one above and you put one below. Kind of looks like a diamond, kind of, sorta, and when you're done with it. And so now, do they match geometry of the introduction? They should. They really should. If you didn't, then hit me up for help. But if you have any questions or something, or if you can figure it out, you can explain why. And the shapes here, you can see, we already talked about that before. So hit me up if you have any questions. This is a fairly safe lab.